So this is the area under the curve from -1 to x. So we're supposed to fill in the value for all of these things that we see here. Now, the problem is that -1 is right here. So -3 is like we're going backwards, right? Because remember when I told you here that this number right here, that is your lower limit, and then the number up here is your upper. So we really want the lowest number to be on the bottom, and it wouldn't be if we had -3. So I'm going to not do that one yet. We're going to come back to it in a second. Or -2, but at -1, if I'm looking at the integral from -1 to 1 of f of t dt. I'm sorry, -1 to -1. What's the area under the curve from -1 to -1? It's going to be 0. Because it has no width, right? Its width is 0, so it doesn't matter what the height is. It has no width at all. So, and we're going to look, on Monday we're going to be looking at properties of integrals, and that's one that we'll see. If you have an integral from a number to that same number, it's always going to have an area of 0 there. So if we have the integral, so this one right here, if we're looking for g of x, it would be our integral from -1 to 0 of f of t dt. So that's the area under the curve from -1 to 0 here. So we'd be looking at this. What's that area? 1/2. Yep, half of the square. All right. Then what about from -1 to 1? 2. What about from -1 to 2? 4. What about to 3? I think it's 5. I think you got 2/3 of a block right here, and then you have a third. And or think about it as triangle formula: 1/2 times 1 times 2 would give us 1. So we'll have 5. Yeah, I think Thomas will be good at this too. All right. So now, I really should have used a different color besides red. Let me switch. I'm gonna use green right here. So we found all of this area so far. It was green. All right. Now, what happens when we go over here to 4?
It starts subtracting.
It is underneath the x-axis. So when that happens, you're going to count it as a negative area. Okay? So this, if we're doing the integral from -1 to 4 of f of t dt, we already found the integral from -1 to 3 of f of t dt. So we're really just adding on that sliver from 3 to 4. And so that first part is positive. That green area is positive. It is 5. Because this is below the x-axis, it's going to be negative. So it has an area of 1, but it's going to be -1, so we will get 4 for that. So when you have an area underneath the x-axis, it has a negative area. Whenever you have an area above, it's positive. So here,
That's only for the x-axis. It's only for the x-axis.
just for x-axis. Sure.
Wait, so would you think of it as a velocity? Like that?
Yes, you can think of it like velocity. Yeah, because if your velocity is negative, that means you're going back the other way, so it would take away from the distance that you've traveled. Yeah. So if we go to 5, that would add 2 more blocks here, but it's really like it's subtracting 2 blocks, right? So that would be back to 2. Right here to 6, we would subtract 1 1/2. So we'd be back down just to 1/2. And then right here, notice the area of my green trapezoid is the same size as my area of the red trapezoid. I'd have 0. It's rotated around that point 3, 0 here. More or less, yeah. Okay, so is that easy enough to understand area under the curve? If it's below, it's going to be negative. All right, now here is where things are a little bit tricky. So when I start, if I go back up here and try to fill in -3 and -2. So if I'm finding g of -2, that is the interval from -1 to -2 of f of t dt. So the problem with this is my lower limit's not really my lower limit. My lower limit is really my upper limit because it's my highest number, right? So I can rewrite this like so. I can put the lowest one on top, on bottom, and the highest one on top, like this. But if I do that, I've got to change the sign. So whenever you have a limit that's going backwards, it's going to change the sign of whatever it normally would have been. So the area here from -2 to -1 would be -1/2. But because we're going from -1 to -2 instead of -2 to -1, right? It's going to change the sign, so it actually is a positive 1/2. So it's negative because it's below the x-axis, but then it turns to positive because when you're going backwards, it changes its sign. Because we started from this point right here, and now we're going back this way, and that changes the sign.
And that changes the integral sign going behind the lower limit. Right?
Yeah, it changes the sign.
Yeah. And just because in this instance it's below the x-axis, it's negative also. So the two negatives.
Right. Double negatives make that positive.
Clarifying. I know that's what you said.
Yeah. So, if we go to 3, again, still a negative value, but you're going in the opposite direction. So that's another 1/2, so we'll have 1 there. Okay. All right, so questions so far? All right, let's now do what they ask us to do here on the next page. They ask us to graph those points that we just found. So we had 1, 1/2, 0, 1/2, and I think it was up to 2. Then where did it go after that? 4?
Yes.
2 is 4,
4,
5.
4, and then it repeats. So you back up.
Like so. So we're just graphing those points from the table that we just made.
Wesley Nation looks a lot like the
He's been holding that in all day.
He's been waiting just to come inside. He's going out of nowhere.
We were talking about Andy Griffith earlier.
That's relevant.
Just delayed.
Yeah.
All right. So, I've kind of drawn in a curve. It may or may not look exactly like that, but probably follows more or less that there. So, the graph that was already there for us, that is our f of t, and then this graph that I have just graphed here, this is our g of x, or g of, I guess, x. here. So, I think they've got an X on the axis here, right here. So I think we would use an X for that. All right, so since g of x was the integral from -1 to x of f of t dt, when we take the derivative of g, we would get just f of x, right? Because this is that same thing we were doing yesterday. Well, let me check your assignments. Yeah, I can check Delta Math later, though, because you don't have to show it.
All I got was like square root of 3x. I don't want to talk about my Delta Math. I finished it, but geez. I started it right when you bell, like before the bell ring, and I finished at like 6.
I started at like when you
I never did that.
All right. Yes, Chandler? The derivative of root 2x, it's 1/2 2x to -1/2 times 2. That's what you'll eventually get, because you got your 1/2 times 2, so you get 2x to the -1/2. Yeah, you got to keep that 2x on the inside there, because it's chain rule for that. So you're doing 1/2 times the 2x to the -1/2. Leave that inside part alone at first, and then you multiply by that derivative. No, so that's because it's inside of that parentheses. So when you're doing the 1/2, you're multiplying out here by 1/2. So if you had, it's the difference in having like the square root of 2x versus having 2 times the square root of x. Those are different. So if it's inside of the parentheses like this, then you would have to do it like we have over here. If you have this, it would be like 2x to the 1/2, no parentheses. So that's when you just get x to the -1/2. All right, so f is the derivative of g right here. So on what intervals is the graph of g increasing? So if we're looking at our red graph here, where's g increasing? -1 to 3. So we can look and see here that we're increasing, or we also could see that our derivative is positive. It's above the x-axis for that section. We're decreasing -3 to -1. Not -1 to 3.
From -3 to -1.
-3 to -1 right here. Where else? 3 to 7.
It's from 3 to 7.
3 to 7.
I thought I said, oh, 3, yeah.
Okay. All right. When is G going to be concave up?
So let's see, G drawing the positive, so when F is increasing.
Okay, so it looks like it's concave up from what I have drawn from -3 all the way to 1. But if we look at our derivative has to be increasing to be concave up. So we would only be increasing from concave up from -2 to 1. This actually right here would be like a perfectly straight line. Same thing right here. You'd have a perfectly straight line. No. Actually, that would be a little bit concave down right there. Right here, we'd have a perfectly straight line because we have a constant rate of change there. Where else are we going to be concave up? 5 to 7. So you can see that it looks concave up here, and we see our derivative increasing. So 5 to 7. If the derivative is increasing. Because if that derivative is increasing, then the second derivative would have to be positive. Alright, for concave down, we'd look for where derivative is decreasing. So, -3, -2. Where else? 2 to 4. Okay, so in both of those places, we see that our derivative is decreasing, causing our function to be concave down. Mine did not look very concave down right here. But. All right, questions? All right, local minimum. Where are we going to have a minimum?
Where the x equals -2.
That would be the minimum. X equals -2 would be the minimum of the derivative of the f. So where is g going to have a minimum?
-1.
At -1. And so we can see just by our graph that's our low point on the graph. But what is happening with our derivative there?
It's constant. It's increasing.
It is switching from negative to positive. That's what tells us that we're going to have a minimum there.
Yeah, that's right.
So,
Like a refresher.
all right. What about our local maximum? Right here at 3. And what happens with our derivative there?
It switches from a positive to negative.
Positive to negative. So that gives us a maximum at x equals 3. And it says, how can you use the graph of f to determine where y equals g of x? Actually, this is how can you use the graph of f. I should have been answering that. At x equals -1 because f switches from. I think it'll be okay. I think that's pretty standard. Yeah.
They don't let us use plus or minus, but they let us use that.
They might let you use plus or minus. I'm just afraid to use plus or minus. I don't know when they're sending out invitations to be graders. I got that backwards this year, but I want to be a grader so I can answer those questions better. But I think it's in Ohio. I think some are doing online grading so you can grade from home, but I would rather go out there. Especially at least the first one. Yeah, my house might not be standing when I return. If I'm not there for 10 days straight, there's no telling what will happen.
You can just get an aggravator.
Yeah, she might quit. Yeah. He's pretty funny sometimes. But he can also be very difficult, but he is funny.
One time, one of them wanted to go play soccer when it poured rain, like it did. Maggie had a rainy wet shoes on. She was like, I guess we're going to play soccer. She should have just told him that, but yeah. That was Hunter, I'm sure.
Yeah, I think it was. Yeah. if I get picked as an AP grader, Margaret, I might have to call you in because
All of the whole.
the whole AP class is gonna. It might take all of you.
I only hired Margaret.
Yeah. And the other person who sometimes babysits for me is Maggie Tomlin. So there is this trend here. Yeah. F switches. Positive to negative. I haven't had to. My mother-in-law has retired, so I haven't had to get babysitters as much as I used to. I used to need one every work day. The children will drink Mountain Dew and eat takeout food all 10 days if I'm gone. And Henry, a while back, Walmart gave us somebody else's order, so there were two liters of Mountain Dew in there, which I never buy. So I finally let him open one of them the other day. So Henry has been wanting to drink Mountain Dew every time he opens the refrigerator. Then he drank all of the Mountain Dew, and it's a 2-liter bottle, and so he would fill the bottle back up with water, and he kept calling it his water bottle, and for 3 days he's just been drinking water out of an empty 2-liter Mountain Dew bottle. I'm going to have to eventually throw it away. It's going to get nasty. Yeah. Yeah. I guess he's still pretending he's drinking Mountain Dew, maybe. He just loves it so much. If I let him continue on this path, he will become Daniel. Start with hard stuff, maybe middle school. All right. Okay, so all right, so points of inflection. How can we tell the difference? We see our concavity switches. So if F is increasing, what does that tell us about G? Concave up. Right. So if F is increasing, G is concave up. If F is decreasing, so what we have here basically is you've got G of X is like your original function. F is the first derivative right here. And then F prime would be the same as the second derivative of G. So if you know that F is positive, it tells you G is increasing. If it's negative, you know G is decreasing. Then you move that down. So if this is positive, then your F would be increasing. And if this is negative, you'd have decreasing here. And if you got a positive second derivative, that tells you your concave up and then concave down. So you're going to see them do this a lot on the AP exam. The FRQ questions I've given you so far have all been like maybe position and velocity and acceleration, or it gives you X and then you find X prime, or Y and Y prime and Y double prime. It's not used as integral define notation before, but it really works as the same as the stuff that we've seen before. As far as the relationships that go on there, it's just the way they're defining the functions is a little bit different. It's really all that you are going to see. So, you have on the next page, you've got all of these graphs right here. And so they want you to use these graphs to answer the next questions that you see. So they give you this example for number 1. It says the graph of y equals g of x is increasing from 0 to 4. And let me explain a little further. For each graph is given here from 0 to 4. G is the integral from 0 to x of f of t. All right. So all of these graphs that you see here are f. G is the integral from 0 to x of f. So what is the derivative of g? The derivative of g is f, right? So basically what this is telling us is we are looking at the derivatives here, and we want to tell what would be happening with g, the function that would be, what we're going to learn is the antiderivative of this. So, if g is increasing from 0 to 4, what has to be true about f? F has to be positive everywhere. So which graphs there do you see that are positive everywhere? E, G, K, and J. So those are your ones that you have as your answers there. And the reason is that their F is positive for all of these. So you're going to use those to answer all the rest of these questions. I'm going to let you guys take about 10 minutes and try those on your own, and then we'll check to see how you guys have done. What'd you guys get for number 2's wanting to know it's decreasing from 0 to 4? F and H. Very good. And that is because F and H are negative on that interval. All right. Scroll down. All right. What about for 3? Constant. None. Okay. Because this is the derivative you're looking at on all of these. So even K, where K is constant, the derivative of that, or the value of that is 2, which means you at least have a slope of the line that's 2. So that would be a slanted line whenever you do that. So there's none for that one. Okay. What do you guys get for number 4? Okay. You should get A, C, I, and J. And what are you looking for there? Increasing. So A, C, I, and J are all increasing for the entire interval. So then for 5, you're looking for concave down. B and D. And that is because F is decreasing. All right, for 6, you're looking for one that has a local maximum at 2. No. All right, so maximum means that our derivative has to go from positive to negative. So B goes from positive to negative at 2. D also goes from positive to negative at 2. And I think those are the only 2. Yes. So all of these graphs are looking at the graph of f, which is the derivative of our g function. So all the questions are asking us about here are asking about y equals g of x. So they're asking us about g. We're having to tell that from the derivative. So like E or F has a maximum at 2, but it's not asking us about F. It's asking us about what this derivative would tell us about G. Does that make sense? Okay. What about 4, 7? Correct. We need negative to positive. you should have A, C, I, and L. 7. A, C, I, and L. Now, 8 is going to ask us about a point of inflection at 2. So, point of inflection would mean that we have to switch from increasing to decreasing or decreasing to increasing, right? Because we can tell concavity by whether or not our derivative is increasing or decreasing. So, which ones are going to have points of inflection? E, F, H, not L, G. Yeah, it has to change from increasing to decreasing. G, H, E, F, and I think that'll be it for those. So you have to change from increasing to decreasing or decreasing to increasing for that. Okay, then we want to know which ones are concave up from 0, 2 and concave down from 2, 4. Again, it's not asking you about the functions you're looking at. So if we're going from concave up to concave down on the derivative, that's going to be increasing to decreasing. All right, so which ones go from increasing to decreasing at 2? F, G. I think that's it. No. Oh, I skipped a problem. I was doing number 10. It is F and G. 9 was, is it increasing to decreasing? So we're really thinking positive to negative. That happens on B and D. All right, for 11, no local extrema would mean that you do not switch from positive to negative at all. So there's several of them that this happens for: E, F, G, H, J, and K. Basically, any of them that do not cross the x-axis. And then for no points of inflection, K is definitely one of them, but you have a lot here. Points of inflection, to have a point of inflection, you have to switch from increasing to decreasing or decreasing to increasing. So any of them that always increase or always decrease are going to have no points of inflection. So A does not have any points of inflection. B, C, D, I, J, and K. Basically, any of them that don't have any maximums. Okay, so I would like for you to finish this up for your homework. So it is just asking more questions like the same thing that we've seen here, asking about increasing and decreasing on the intervals.
Is that page 8, 9?
8, 9, 10. Yes.
So page 8, 9, 10.
Yes. So 8, 9, and 10, finish that up for me.